Meta has released an AI model designed to do something very different from the giant systems running inside enormous data centers. It is designed to run on your own computer. The new model is called Muse Glimmer. According to Meta, it can perform agentic tasks on a Mac or PC using a single graphics card, giving developers a way to build AI that works locally instead of sending every request to a remote cloud server. At the same time, Mark Zuckerberg has published one of his strongest arguments yet for OpenAI. His message is simple. Advanced intelligence should not end up controlled by a handful of companies or governments. And behind that argument is a much bigger strategic concern. China is becoming extremely competitive in open-weight AI. DeepSeek, Alibaba and Moonshot have released increasingly capable models that developers can download, customize, and sometimes run themselves. Meanwhile, the strongest systems from OpenAI, Anthropic, and Google remain largely closed. Meta is now betting that America cannot win the next AI race by keeping every powerful model behind an API. Muse Glimmer is the first piece of that strategy. The model is deliberately smaller than frontier systems such as the largest Gemini, Claude, or OpenAI models. That might sound like a disadvantage. But Meta is optimizing for a different target. Imagine two types of intelligence. The first lives inside a gigantic data center. It can solve difficult problems, process enormous amounts of information, and use thousands of expensive processors. The second lives directly inside your laptop. It may not be as intelligent, but it can see your files, operate software, complete routine tasks, and respond without sending sensitive data across the internet. For many applications, the second system could be more useful. That is the opportunity behind local AI. Most current AI products work like remote utilities. You type a question. Your device sends information to a server. The server runs the model. The answer comes back. This architecture made sense because powerful AI models were too large to run on ordinary computers. But it creates several problems. The first is cost. Every request consumes expensive computing resources. If millions of people use an AI agent continuously throughout the day, cloud inference becomes an enormous expense. The second problem is latency. An agent controlling software may need to make hundreds of small decisions. Sending every decision across the internet creates delays. The third is privacy. An AI that becomes truly useful may need access to personal documents, software projects, photos, business records, emails, and other sensitive information. Many people and companies do not want all of that data transmitted to an external provider. Local models change the equation. Muse Glimmer can potentially handle simpler tasks directly on the machine. A more powerful cloud model can then be called only when necessary. This creates a hybrid architecture. Think of it like having a competent assistant sitting beside you and a team of world-class experts available by phone. The local assistant handles routine work immediately. Only the difficult problems are escalated. That could dramatically reduce the cost of AI agents. And agents are becoming one of the central battlegrounds of the industry. A chatbot waits for instructions. An agent can take actions. It might organize files, modify code, search documents, operate applications, create reports, or complete multiple steps toward a goal. Meta says Muse Glimmer is specifically designed for smaller agentic workloads. That distinction matters because an agent may generate far more model calls than an ordinary conversation. Ask a chatbot one question and it might produce one answer. Ask an agent to analyze a software project and fix a bug, and it may inspect dozens of files, run tools, evaluate results, retry failed approaches, and verify the final solution. One task can create hundreds of inference operations. If every one of those operations requires a premium cloud model, costs can escalate quickly. Move routine reasoning onto the user's hardware and the economics change. Meta is not stopping with Glimmer. The company says it also plans to release the weights of Muse Spark 1.2, its most advanced model so far. Muse Spark 1.2 already powers Meta's new Muse Code programming agent. Meta says the model can write and debug code, work on long projects, verify results, and operate multiple subagents simultaneously. The company trained the model and coding tool together. That is significant. Instead of creating a general model and later attaching it to an application, Meta can optimize the intelligence around the task it wants the system to perform. This is similar to hardware-software co-design, except now the co-design is happening between the model and the agent surrounding it. Meta is effectively building an AI stack. At one end are small models that can run locally. Above them are stronger cloud models. Then come agents capable of using software and tools. At the top are Meta's enormous distribution platforms: Facebook, Instagram, WhatsApp, smart glasses, and its standalone AI services. Meta can potentially place intelligence across every layer. But the most controversial part of this strategy is openness. Muse Glimmer is an open-weight model. That does not necessarily mean every detail of its original training process or dataset is public. It means developers receive the model weights, the mathematical parameters created during training. With those weights, organizations can run the model themselves, modify it, fine-tune it, and build systems without sending every request back to Meta. This is fundamentally different from a closed API. If a company builds on a closed model, the provider controls access. The provider can change prices. It can change policies. It can update the model. It can restrict particular uses. It can eventually shut the service down. With open weights, developers gain much more independence. Zuckerberg argues that this distribution of power is important. He has warned that concentrating advanced AI inside a small number of companies or governments could produce worse outcomes for everyone else. His alternative is what he describes as broadly distributed intelligence. In his new essay, he imagines personal AI systems helping people learn, create companies, invent products, and receive highly personalized assistance. The argument sounds idealistic. It is also deeply competitive. Meta needs OpenAI to work. OpenAI already has ChatGPT. Google controls Gemini and has Search, Android, and enormous cloud infrastructure. Anthropic has become a major enterprise AI provider. Meta has billions of users, but its previous Llama 4 generation failed to create the momentum the company wanted. Meta then spent aggressively to rebuild its position. It created a new superintelligence organization. It brought in Scale AI founder Alexander Wang through a deal worth more than $14 billion. It offered extraordinary compensation packages to recruit researchers. Muse became the first major model family produced by that effort, and Meta initially moved away from its previous open strategy. Muse Spark was introduced through controlled access rather than immediately releasing its weights. Now the pendulum is moving back. One reason may be China. Chinese AI companies have turned open models into a strategic weapon. DeepSeek showed that highly capable models could be offered at dramatically lower prices. Alibaba's Qwen family has become widely used by developers. Moonshot's Kimi models are competing on long context and agentic capabilities. These systems give developers alternatives to American closed providers. For Zuckerberg, That creates a national competitiveness problem. If American companies place increasingly strict restrictions around their models, while Chinese developers distribute strong alternatives openly, the global developer ecosystem could gradually shift toward Chinese technology. Once applications, tools, and businesses are built around a model family, switching becomes harder. The battle is therefore not simply about which model scores highest on a benchmark. It is about which ecosystem developers choose. Open models spread differently from closed systems. A company can download one. A university can study it. A startup can fine-tune it. A government can deploy it internally. Researchers can create new versions without asking the original developer for permission every time. That can accelerate innovation. But it can also accelerate misuse. This is the strongest argument against releasing increasingly capable model weights. Once a powerful model is downloadable, the original company cannot remotely disable every copy. Safety filters can potentially be removed. The system can be fine-tuned for activities the creator would prohibit. Cybersecurity makes this tension particularly difficult. Recent incidents involving AI systems performing unintended cyber actions have raised concern about giving powerful agentic capabilities unrestricted access. Meta itself has faced questions about how increasingly autonomous AI should be controlled. Zuckerberg's answer is not that risk does not exist. His argument is that concentrating intelligence may create an even greater risk. Meta says it plans to create a governance process in which independent directors can approve safety criteria for future model releases. That suggests the company does not expect every future model to be released automatically. Capability and risk will need to be evaluated. The debate becomes harder as models improve. Releasing a model capable of summarizing documents is one decision. Releasing a model capable of autonomously discovering serious software vulnerabilities would be another. Where exactly should the line be drawn? There is no industry-wide answer. OpenAI and Anthropic generally argue for tighter control around frontier capabilities. Meta is arguing that too much control itself creates dangerous concentration. Chinese developers are applying even more pressure by making increasingly capable models available to the world. This is turning OpenAI into a geopolitical competition. And there is another physical dimension to Meta's strategy. AI openness means little if nobody can afford the hardware needed to run the models. Muse Glimmer is interesting precisely because Meta says it can operate using one GPU. That moves meaningful agentic AI closer to ordinary developers and small companies. The industry has spent years moving intelligence into enormous cloud facilities. Smaller models may begin moving part of it back. Personal computers could become AI servers. Workstations could run private agents. Companies could keep sensitive workflows inside their own buildings. Future phones may perform increasingly complex tasks without constantly calling cloud services. This does not mean giant data centers disappear. The strongest models will still require extraordinary computing power. Meta itself expects to spend as much as $145 billion this year, much of it related to AI infrastructure. The company is simultaneously arguing for distributed intelligence while constructing some of the largest computing systems on Earth. That looks contradictory. But the two strategies can coexist. Meta can use giant clusters to train increasingly powerful models. Then it can distill, compress, or specialize parts of that intelligence into smaller models that run elsewhere. The data center becomes the factory where intelligence is created. Personal devices become the places where portions of that intelligence are deployed. This may be the architecture Meta ultimately wants. A massive central model develops stronger capabilities. Smaller models inherit selected abilities. Those models run on laptops, phones, glasses, robots, and other devices. When they encounter something too difficult, they call the larger system. Intelligence becomes hierarchical. And if Meta releases many of those models openly, an ecosystem can grow around them without Meta having to build every application itself. That is how open-source software transformed computing. Linux did not dominate because one company designed every product running on it. It became powerful because millions of developers could build on top of the same foundation. Meta wants OpenAI to create a similar effect. Whether Muse can actually become that foundation remains uncertain. Open models from China are improving rapidly. Google, OpenAI, and Anthropic continue pushing frontier capabilities. Developers increasingly care about coding performance, agent reliability, context length, cost, multimodal understanding, and tool use rather than philosophical arguments about openness. Meta must still produce models people genuinely want to use. Muse Glimmer therefore matters less because it is the smartest AI released this week. It almost certainly is not. It matters because it represents a different answer to the future of artificial intelligence. One future places increasingly powerful intelligence inside a few giant cloud platforms. Users rent access. Companies control the models. Every important request travels through centralized infrastructure. The other future distributes more intelligence onto devices and gives developers direct control over the models themselves. Meta is betting on the second future. Not entirely. Its strongest systems will still live in enormous data centers. But Muse glimmers a step toward making local AI powerful enough that the cloud does not need to make every decision. And Zuckerberg is turning that technical choice into a political argument. America, he says, should not respond to AI risk by locking advanced intelligence inside a handful of corporations. It should compete by spreading it. The next AI war may therefore be fought on two fronts. One race will build the smartest model. The other will decide who gets to control it.